Okay, so for 15, 16, and 17, we're going to talk about the notion of a function being even or odd, or perhaps neither even nor odd. And then on 18, we're going to graph an absolute value problem, much like we did in the previous situations. And then 19 and 20, we're going to find inverses. All right, so the thing to remember is for even, we want our initial function to be the same as if we flipped it horizontally. Notice we were multiplying by a -1 within the function, so that's a horizontal flip. So basically we're saying around the y-axis, it's symmetrical. Okay? So all we need to do is determine when we put in a -x, do we get the same thing? Is it the same as having a positive x? Well, if we look at 15, anywhere we have an x value, we are raising it to an even power. So that tells us that if I had -x to the fourth, the negative x in parentheses raised to the fourth power, that's a negative times a negative times a negative times a negative, which gives us a positive. So we're going to have the same situation. And then analogously here, we have -x squared is -x times -x, so we get a positive x squared. So this is going to be the same thing. So that's definitely even. Now, this problem, if we put in a -x, we're raising this to the fifth power, so this would, instead of being x to the fifth, would become -x to the fifth. In the same way here, we have x to the third, so that would become -x to the third because we have an odd. Okay? So this is not even. Then we look here, we have this to the fifth power again. Now this one is even, so this part would be the same, but this part is not going to be the same because we have it raised to the fifth power. So this one is not even either. So then we can check, is it odd? Now, odd is similar to even, except we're looking for two flips. We're saying I flip it horizontally, and then I also flip it vertically. And that's also kind of thinking about a rotation around the axis. So if I flip it horizontally and vertically, do I get back to my original situation? So one way we could think about that is if I put in those negatives and then I multiply everything by a negative at the end, does that happen? Well, we talked about here how if I put in the negatives, I get -6, and then I get -5 times -5 times -5 times -5 times, or sorry, -x times -x 5 times. So -x times -x times -x times -x times -x. And all those leave me with a -x to the fifth. And then in the same way here, I have my 3 times what's going to end up being -x cubed. So now these two negatives can cancel, right? And I can bring this negative here. Now if I take my outside negative and I say, okay, well now I'm going to multiply everything by a negative again, multiply this whole thing by a negative, that means I distribute through, so this becomes negative, this becomes positive, and notice we're back where we started, so this must be an odd function. Okay. And we can check that here. Here I have a -6, and just like here, if I put in the negative, it's going to be -x to the fifth. And here I have 3 times -x squared, which is just going to give me x squared. So these become positive because I have a negative divided by a negative. So now when I run my negative through, this negative, this becomes negative again, and this positive becomes negative. So now I have a negative and a negative, but originally I started with a negative and a positive. So this is neither even nor odd. Okay, now let's look at our graphing. So just like we had before, if we think about what our kind of base state is, we have our absolute value of x, which looks like that. Now from here we can see that I need to put in a 1 in order to adjust for that. So I've shifted over 1. I also know that whatever happens at the end, I'm going to add 3 to that. So I've shifted up 3. So that's one way I can say, okay, my vertex definitely is here. Okay. Now what does that -2 do? That -2 is outside of the function. So we can also kind of get a feel for it. Let's say we put in a 0 for x. If I put in a 0 for x, I get -1. Absolute value of -1 is 1. So I get -2 times 1, which is -2, and then plus 3, I get +1. So here I'm at +1. Now notice in this case, every time I move my x1, I shift my y value, or my g of x1. In this case, I'm moving 2, and you can also see, of course, I'm moving downward. So what this is doing is I'm vertically stretching it, and I'm also reflecting it so that it's opening downward. All right, so let's look at 19. We're trying to find the inverse. Well, when we find the inverse, what we're doing is saying, what used to be my input, I want it to be my output, and what was my output needs to be my input. So if we rethink of this as like a y, then I can say, now my new input, where my output used to be, I put my input, and where my input was, I put my output. Okay. And now I can solve for y, and when I solve for y, I'm going to be creating my inverse. Okay. So as I do that, I'll add 3 to both sides, and then I'm going to divide by 5. Oops, and there's an equal sign there. So I get y equals x plus 3 all divided by 5. Okay. So that is my inverse. Now, if we want to, we can kind of prove that these are inverses, right? If I take the inverse of the function itself, by definition, I need to get back to my original value. So now if I do that here, I'm saying my original function plus 3 divided by 5 should give me x. So I'm going to put 5x minus 3 here, and of course 5x minus 3 plus 3 is 5x. So 5x over 5, of course we get x. So we know we've done it right. Right, so in the same way we can approach this. I'm going to go ahead and change my inputs and outputs. Now, when I want to write it in function form, I need to just have my one input value, or sorry, my one output value, which will be my y. So I want to figure out a way to get those y's together. When I have a situation like this, maybe my first step is try to think, okay, what can I do to move this problem forward? I have this division. Maybe I'll multiply both sides by the denominator so I don't have a fraction anymore. So when I do that, I have x times y plus 4 equals 2y minus 7. Now I'm going to distribute that through, so I have xy plus 4x, and then of course still equals 2y minus 7. And now what I want to do is try to get my y's together. So first I'm going to need to get them back on the same side. Now the reason I moved the y to the other side originally is because I couldn't find a way to connect these. But maybe if I rearrange things, I'll be able to find a way. So I'm going to go ahead and add 7 to both sides. And I'm also going to subtract my xy. So now I have 2y minus xy. And actually now I'm in a really good place because I notice that my two terms have a y in common, so I can factor that y. So I get 2 minus x, 4x plus 7. And now all I need to do is divide both sides by 2 minus x. And when I do that, my 2 minus x's cancel, and I've got y equals this. And remember that my y is, of course, my f inverse. My f inverse of x is now 4x plus 7 over 2 minus x.